All right, so what we're going to look at is how you find a particular solution, which is different than when you found a general solution. And this is the back of the doodle notes that you have from the last time you had class. So a particular solution is finding C. So what this means is that you're just going to find the C value. And in order to find that constant value, you have to be given a x and a y. So if you look at my first example here, it says g prime of x is equal to 4x squared. So the differential is 4x squared. So if I integrate, remember that symbol, so I'm going to integrate 4x squared dx. So if I use my integration rules, I'm going to add 1 to the exponent. So I get 4x cubed over 3 plus c. So that's what my function g equals. So g of x is equal to 4x cubed over 3 plus some constant value. And remember, that could be 5, 100, negative 12, 1.2, pi. It could be any constant. But a particular solution wants just one of those solutions. So this is called a general solution. I want just one solution. So you were given that g at negative 1 equals 3. So that means at negative 1 is the x value, the y value, or the function value is 3. So you solve that equation. So 3 equals 4 times negative 1, I don't know why it keeps doing that, to the third over 3 plus c. So get out your calculators, unless you're ready to do fractions. Negative 1 cubed is negative 1, times 4 is negative 4, so you have negative 4 thirds. So if I move that to the other side, 3 plus 4 thirds is going to give me 13 thirds, or 4 and 1/3. So the answer to this is going to be that g of x is equal to 4x cubed over 3 plus 13 thirds. So what you did is you found the c value. And why is that useful? The purpose is right below. If you read through this problem, it's just like a physics problem. You could use physics to find the answer. I'm going to use calculus. The formulas are similar. Hopefully you'll see the connection to them. It says a ball is thrown upward with initial velocity of 64 feet per second from initial height of 80 feet. So first we have to find the position function of the ball, and then we want to know how long does it take for the ball to hit the ground. So let's start by talking about what unit we're in. We're in feet per second. So I know that I'm throwing the ball with initial velocity of 64 feet per second. So we have a velocity. We're going to be talking about a velocity function. And then we have a height, which is also the position. So the height and the position function go together because height is position. To do this problem, though, we have to go back even one more step in thinking of derivatives. When we had derivatives, we would go from position to velocity to acceleration. So I know that acceleration, my acceleration function, that I'm going to use is negative 32 feet per second squared. And remember, if you were in meters, that would be 9.8, but we are in feet. So that's an acceleration function. So we did these a long time ago, but we did derivatives. Now we're doing antiderivatives, or finding particular solutions. So if I want to go from acceleration and I want to change that function to velocity, so I want the velocity, I'm actually going to change this. Let's make this a of t, because we're talking about time. So if I want the velocity function, I would have to take the antiderivative. So to go from acceleration to velocity, I have to do the antiderivative. So negative 32 is a constant, so the antiderivative of a constant would be negative 32x, or in our case, t, because we're talking about time, plus some constant. So we need to find that constant, so we have a velocity function. What were you given about the velocity in the problem? It says a ball is thrown upward with initial velocity of 64 feet per second. So in physics, you call that v naught, the initial velocity. So that's when the time is 0. So time equals 0. When the time is 0, the velocity is 64. So we can put that in. That's our ordered pair. So 64 equals negative 32t, which is 0, plus c. So c is 64. So far I have a velocity function that would be negative 32t plus 64. So we're at velocity. We went from acceleration to velocity. But then we also need the height. So to go from velocity to position, I do the antiderivative again. So the position function, I use s of t. I'm going to take the antiderivative of negative 32t, which would be negative 32t to the second divided by 2. That's going to give me negative 16t squared plus the derivative of antiderivative of 64 is 64t plus c. So this is my position function. All right, I have to hit pause to plug in my computer. Okay, so now that we have our position function, which is right here, negative 16t squared plus 64t plus c. Negative 16t squared is half the acceleration times time squared, or 1/2 at squared. Plus, this is v naught plus c. I still have to find c, which I haven't done yet. So I'm going to move that up here. What can I use to find c? Well, it says my initial height is 80 feet. So that means that 80 is equal to negative 16 times 0 squared plus 64 times 0 plus c. So when you solve all that, you just get 80 is equal to c. So my position function is negative 16t squared plus 64t plus 80. So in Algebra 2, you look at functions like this. This is 1/2 at squared plus the initial velocity plus the initial height. It's kind of the form that they all have if it's a quadratic. So that's part A. Part B says, when does the ball hit the ground? Well, when the ball hits the ground, that's a position. So I'm going to use position. And the ball hits the ground, that would equal 0. So 0 equals negative 16t squared plus 64t plus 80. So you have a quadratic. You can either use quadratic formula, because this is a book problem, I'm assuming it can factor. So I'm going to take negative 16 out of it. And, sorry, I get 0 equals positive t squared minus 4t minus 5. So I get t minus 5 and t plus 1 when I factor. Obviously time is not negative 1, so the answer to that question is 5 seconds. The ball is in the air for 5 seconds. It hits the ground at 5 seconds. All right, so the other thing that you might see a couple little problems on your assignment are given a derivative graph, what would the function look like? So this is a derivative graph. It's a line. So most of you know that if the derivative's a line, the original function would be a parabola or a quadratic. But what does that look like? Well, I know right here is where my function, my original function, has either a maximum or a minimum because it's a 0 of the derivative. And then I also know that my derivative is negative here. My derivative is positive here. So that means my function is increasing. So when your derivative's positive, you're increasing. And then from 1 to positive infinity, my derivative's negative, so my function is decreasing. So back when we did curve sketching, this would be like negative infinity to 1, my function is increasing. And then 1 to infinity, my function is decreasing. So if I go from increasing to decreasing, that means there's a maximum. The maximum happens when x equals 1. So here is a maximum. Do we know the y value? No, you can approximate. I'm going to say it's like right here. So my function went from increasing to decreasing, like that. So if I look at the second graph that I have here, this is a quadratic, so my original function would be a cubic. I know that there is either a max or a min at 0 and at 3. Those are the critical points because they're where the derivative equals 0. So again, here my function is increasing because my derivative is above. From here to here, decreasing. From here to here, increasing. So I go from negative infinity to 0 of increasing, so it's going up, 0 to 3, decreasing, my function is going down, and 3 to infinity, increasing, my function is going up. So I'm going from increasing to decreasing, so it increases, and then it decreases, and then it increases, like that. So those are particular solutions. Going back to this first example, this one just gave you the first derivative. Here we actually did the antiderivative twice because acceleration is technically the second derivative. So you could really do this with you could start with the fourth derivative and just take the antiderivative that many times to get back to the original function. All right, you have an assignment on WebAssign that's called particular solutions. So you can work at that.